Hello everybody. Today Ruby Sharma will be explaining to you about symmetry. We'll be doing line symmetry and rotational symmetry. Okay. Now line symmetry you have already done before. So we'll have a quick recap of what is a line symmetry. A figure has line symmetry if there is a line about which the figure may be folded so that one half of the figure coincides with the other half. Now suppose this butterfly, this is the dotted line. So if we fold it, both sides are identical. This part coincides with this part. Then the figure is said to have line symmetry, and the dotted line is called the line of symmetry or axis of symmetry. Now here also you'll observe, suppose you draw a figure of this and cut it out. Then if you fold it along this dotted line, you'll find both sides are exactly the same. Coincides with the other half. Similarly with this, if you fold it along this line, you'll find it the both sides identical. So this has multiple lines of symmetry, we say. So Taj Mahal also is a very good example of man-made designs having a line of symmetry. So these are other symmetrical figures which you can go through. Geometrical shapes, this is a kite. It has also a line of symmetry. The dotted line is the line of symmetry. If you fold it along this line, you'll find both sides coincide. Similarly with these figures. Even alphabets, you see, A has a vertical line of symmetry. If you fold it along this line, you'll find both sides are same. Here also it has a horizontal line of symmetry. If you fold it along this side, you'll find they are identical. So these are, and this dotted line is called the line of symmetry. And we have regular polygons. First, you should know what is a regular polygon. They are polygons of having sides of equal lengths and angles of equal measure. For example, all these equilateral triangles, square, regular pentagon, regular hexagon, etc. And if you observe, you'll find that the lines of symmetry is equal to the number of sides in case of regular figures. So you can draw, if it's better, if you can cut out a newspaper, out of a newspaper, a square, and you fold it along the dotted lines. First you fold it along this line, you'll find both sides coincide. Then you fold it along this line, you'll find both sides coincide. Similarly with all this, you can try it out. You can cut out a paper, a chart paper, or any other paper, and you can fold and find out the lines of symmetry. The line of symmetry divides a figure into two congruent figures. Another name of the line of symmetry of an isosceles triangle. Isosceles triangle has two sides equal. So the line of symmetry will be from the vertex where the two equal sides meet. So that line of symmetry is called the median or the altitude. Why? See, suppose you have this. This is an equilateral triangle, but let us take two sides are equal, these two sides. So this line of symmetry will be a perpendicular bisector of this. So that is also the median or the altitude. Since it's a perpendicular, it's called altitude. In case of a rhombus, all sides are equal, but angles are not equal. So if you cut out a rhombus and find out the line of symmetry, then you can do this also. Now we come to reflection symmetry. When an object is placed in front of a mirror, the image that is formed is the symmetrical shape of the object. Now see, suppose this is the shape. If you put a mirror, just place a small mirror along this dotted line, you'll find the images like this. That means if you can complete this figure, the mirror will be the line of symmetry. So it is similar, line of symmetry and the mirror image. You can put the mirror here also. You'll find the figure on the image will be in this way. It is same, but it is laterally inverted. It is not like this. It is laterally inverted. So the mirror line, where the mirror is placed, this is the object, this is the image. The mirror line becomes the axis of symmetry. And when the object is placed at a distance from the mirror, then that distance in science you must have studied, this distance and the distance from the mirror and the image is same. This distance and this distance are equal. Similar is the case. So in reflection symmetry, we have the image formed as far behind the mirror line as the object is in front of it. It is laterally inverted. See, if this is a figure, and if this is a mirror, then the image is formed in this way, laterally inverted. Inverted, isn't it? But laterally. And the line of symmetry can be in any direction, horizontal, vertical, anyway. So here are some examples of lines of symmetry. These are multiple lines of symmetry. That means more than one line of symmetry. Now here, if you are asked to draw the line of symmetry, how will you draw? Now in a square, we know it has 4 lines of symmetry. But this is neither a square nor a rectangle, but a little bit different from that. It has an extended part. So the line of symmetry should be such that when you fold it, both sides should be identical. So that is why these are same. So these are line of symmetry, which you also have done before. So you can just go through all these figures. This is from your textbook. Now here, though we know a square has 4 lines of symmetry, in this case, the dots will make the difference. So accordingly, you will see where the dots are placed and how to draw the line of symmetry. So if I draw the line of symmetry vertically, I'll find that these 2 parts coincides. Here also, it has to be drawn slanting way. The diagonal is the line of symmetry. So both sides are identical. So similarly, you can go through these figures and try it out. It's done in your textbook. Now, rotational symmetry is a new topic for you. Now, what do you understand by rotational symmetry? Now, in a clock, you'll find the hands of the clock rotate in a particular direction, and that is called clockwise direction, and otherwise it is called anti-clockwise. Now, the minute hand or the hour hand, whatever it is rotating round the clock about a fixed point. This is the fixed point. It is rotating around. So this fixed point is called the center of rotation. And it completes one complete circle in 360 degree. Complete circle is 360 degree. So minute hand completes 360 degree in 60 minutes. That is 1 hour, isn't it? Now rotation. So when the turning of an object about a fixed point in a clockwise or anti-clockwise direction is called rotation. Just now we saw about a fixed point, the hands of the clock moved. Similarly, we find that blades of a moving fan, it rotates about a fixed point and so on. The fixed point about which an object rotates, that fixed point is called the center of rotation. With example, things will become more clear. One complete rotation is what? When it completes one full turn to arrive at the original position. That is, it rotates through 360 degree. The complete circle is 360 degree. Half turn is 180 degree, quarter turn or 1/4 turn is 90 degree, 3/4 is 270 degree, isn't it? 90 degree is 1/4, 2/4 is 180 degree, 3/4 will be 270, 4/4, that is 4 by 4, one full turn is 360 degree. Now rotational symmetry. An object is said to have, now these things you have to understand very clearly, and accordingly you can try it. An object is said to have rotational symmetry if after rotation about the center of rotation through a certain number of degrees, it looks the same as it did in its original position before the rotation started. Okay, as we do, I'll explain to you what these lines mean. Angle of rotation is what? The angle through which an object rotates before it looks exactly the same as the original position. And the order is what? The number. Now, when an object is rotating, at certain points, it looks like the original part. So, it will rotate through certain angle, maybe 90 degree, 180, 270, 360. At say 90 degree and 180, it looks the same. So the angular rotation, suppose it looks the same at 90 degree also, then even at 180 degree. Like for example, a square. When you rotate 90 degree, it will look same even for 180, even for 270, even for 360. So angular rotation is called 90 degree. First time when it turned 90 degree, it looked exactly the same. Again at this one, 180, it looked exactly the same. So then we say angular rotation is 90 degree. Then what is order of rotational symmetry? Now when it is moving, you can calculate like this, 360 degree by angular rotation. Okay, let us take some examples. Now this one. The smiley turned 90 degree, then 180, 270, 360. Now first time it looked like the original position is at 360 degree. So your angle of rotation is 360 degrees, which an object rotates before it looks the same as the original position. So at 360 degree, it looked the same. So order will be 360 degree and angular rotation is 360. So 360 divided by 360 is 1. Okay, order is 1. Another definition how you can know order is 1. In this rotation, how many times it looked the same? Only once, isn't it? Now let's go to the next figure. Now this one. See, it rotated 90 degree. When you can draw this figure in a piece of paper and you rotate 90 degree. Rotate the paper at 90 degree. You'll find this. At 180 it will be this. 270 and 360, again the original position. Now here, first it looks same at 180 degree, isn't it? So your angle of rotation is 180. So you can do 360 by 180, that is 2. Or you can see in when it rotated, till it completed one full rotation, how many times it looked exactly the same as the original one? 2 times. So you can do that directly that way also. Similarly, this one. Now here you see this, when you rotated 90 degree, it came here. 180 it came here. Every time it is looking exactly the same. So angular rotation is 90 degree. At first point only it looked exactly the same. So it is 90 degree. And how many times it looked exactly the same? 4 times. Till it completed 360 degree. But also you can write 360 divided by 90 is order of rotation. That is 4. Similarly is this. Now here, there are objects which look exactly same after turning an angle through 120, 240 and 360. So equilateral triangle is one of the examples. It is not, when you turn 90 degree, it will not look the same. If you do like this, you turn here, it will not look exactly the same. It has to turn till here. This A has to come to this point to look exactly the same. So this angle, when you measure, it is 120 degree. Again, 120, again 120. That means up till 360, 3 times it looks exactly the same. So you can write rotational symmetry of order 3. And angle of rotation is at what angle it looked exactly the same when it rotated at 120. So angular rotation is 120. And if you use the formula 360 by 120, then also you get 3, order 3. So here are some more examples which you can go through. It's written clearly the order of rotational symmetry. And it also with the help of the diagram. Even this is done with the help of the diagram. This is the original position. So these figures have to be rotated through 120, 240, and 360. Then this is another example already done. You'll get the PDF, don't worry. Now, after 90-degree rotation, about the center of rotation, a figure looks exactly the same as its original position. At which of the following angles will this not happen? If at 90-degree it looks exactly the same, at 180 it will look, at 270 also, 360 multiples of 90. But at 120 it will not look exactly the same. Now what about the order of this rotational symmetry? So turn through 90-degree, this is suppose horizontal position. Then in the vertical position, it will not look like this. Again, in the third 180-degree, it will look as the original position. 270, again, it will not look like this. Again, at 360, it will look like this. So order of rotational symmetry is 2. And the angle of rotation is 9. Line symmetry and rotational symmetry. Some figures have only line symmetry and rotational symmetry of order 1, while some have rotational symmetry. Some figures have both line and rotational symmetry. So some examples are given. Square has lines of symmetry, 4 lines of symmetry. And also rotational symmetry, I've already seen it is 4, isn't it? And rotates through 90, 180, 270, and 360. So angular rotation is 90-degree. At 90-degree, it looks exactly the same. Again, 180. So first, it looks exactly the same at 90-degree. Here, first, it looks exactly the same at 180. At 90-degree, it will not look exactly the same. At 180, it will look, excuse me, exactly the same. And then at 360. So angular rotation is what? 180-degree. And rotational symmetry is of order 2. Next, you have this equilateral triangle. We have done similar examples before also. Then we have, that I'll explain here. What is the smallest number of degrees you need to rotate the following images for them to look the same? So you have to find out the angle of rotation. So how will you calculate here? See, and this is 90-degree, isn't it? But at 90-degree, this part will not come here. So at 45-degree only it will come, isn't it? This is the, suppose this is 90, so this part is 45. So this will move from here to here at 45-degree only. Another way you can calculate is, see, 1, 2, 3, 4, 5, 6, 7, 8. So 360-degree, 8 petals are there. So 360 divided by 8, you get 45. Isn't it? Isn't it? So 45-degree angular rotation. Suppose you have this. Now see 1, 2, 3, 4, 5. So 360-degree divided by 5 will find the angle of rotation. Similarly with this. Now here they are saying write the angle of rotation and the order also of rotational symmetry. Angle of rotation is, it will turn through what? 90-degree you turn, see, the first position, second. You can draw a U in a piece of paper and turn the page. 90-degree, then 180, 270, and 360. So you'll find in the fourth position, it looks exactly the same. So what do you think is the angle of rotation? 360-degree. After 360-degree, it looks the same. And what is the order rotational symmetry? 1, isn't it? Here, this you write S in a piece of paper, rotate it 90-degree, then like this, second position, third position, fourth position. Now, what will you have it? You find that they look exactly the same in 2 positions when complete rotation is completed. When there's a complete rotation of 360-degree at 2 positions, it looks exactly like the original one. So order of rotation symmetry is 2. And what is the angle of rotation? 180 degree. At 180 degree, first it looks exactly as the original position. Order you can do by 360 divided by 180, you get 2. In that case also you can do. Similarly, you can try it out with all these. Now here are some examples which have been solved. Since I'll be sending you the PDF, you can go through these pages, the line symmetry and rotational symmetry. And you have this figure done for you with diagrams. Next, you have this figure, similar to equilateral triangle. Then you have this table, letters of the alphabet. Line symmetry, you already have seen. How many lines of symmetry? You know, O or 0, all these are many lines of symmetry, infinite lines of symmetry. And rotational symmetry is also many. And you can find the order of rotational symmetry. You write C, then you rotate to 90 degree. Like this, it's going to come. Then you you rotate 180 degree. So just write C in a piece of paper, rotate. Then it will come like this. It will come like this, isn't it? Then it will come like this. So in the fourth position, it will look exactly the same. So rotational symmetry, angle of rotation is 360 degree. That means at 360 degree, it will look like the original position, number C, this alphabet C. And order will be 360 by 360. Any method you use, it is one. So I hope that's clear to you. Bye-bye and have a safe